Thanks, Steffi. I have had an amazing time in Germany, so thank you for all of you that have given me such incredible hospitality, and Steffi and the entire DLD team. So yes, I'm Robin Farmanfarmaian. I've actually said my own last name on stage incorrectly. It's that difficult. So how's everyone feeling today? Good? Yeah? Cool. Woohoo! All right, so I'm up here today to talk to you about how the convergence of exponential technology is really empowering what I like to call the healthcare consumer to be a key decision maker on the healthcare team. So let me start out with a little bit about who I am. Right? I'm a serial entrepreneur. I've worked on 12 early-stage startup companies, all in cutting-edge medical technology, biotech, and education. Now, the reason I decided to become an entrepreneur is because as a teenager, I was misdiagnosed with an autoimmune disease. Ended up resulting in 43 hospitalizations and 6 major surgeries. Now, when you're facing surgery, and especially when you're a kid, right, you go from hospital system to hospital system, looking for the very best doctors out there. But none of my doctors ever looked at me and said, you know what, Robin? Why don't we hold off on these surgeries because you're so young and technology is moving so quickly? It could provide better solutions in the near future. Nobody ever looked at me and said, you know what, Robin? Technology is hope. But technology is hope. In fact, had digital health IT and the sheer amount of information we now have access to as patients existed when I was a teenager, I most likely would not have lost 3 organs. At the age of 26, this is 7 years after they had taken out my entire large intestine, my doctors were telling me I was cured. But I wasn't. I was in extreme abdominal pain, extreme, to the point that my doctors put me on 80 milligrams a day of methadone. Anyone who knows anything about the opiate family, that is a massive dose, right? And they were telling me, okay, I was cured, but all the resulting pain was most likely from the sheer amount of abdominal surgery I'd had, and I was going to be on methadone or the equivalent for the rest of my life. What? I was 26 years old, and they were telling me, essentially, I was shut in at that time, like I could not function, right? So I fired my entire healthcare team, every single one of them, including my massage therapist, everyone. I rebuilt it with physicians and healthcare professionals that worked with me as a team, a colleague and a peer, and allowed me to be a key decision maker on the healthcare team. Ended up getting diagnosed correctly, right? Put on a medication called Remicade, and literally within 24 hours of that first infusion, I went into remission overnight. Right? After a 13-year battle, because I took control of my health, I was suddenly in remission. So that's what I'm up here to talk to you about, how the convergence of all of these exponential technologies really empowering the healthcare consumer to be a key decision maker. So later on this afternoon at DLD Academy, I'll do a deeper dive into all of these, including defining what exponential technology really means. Today I've got a few minutes, so I'm going to give you a fast overview. So let's start out with a little scenario, what it's like to be a patient today and in the near future. Well, we have a lot of point-of-care diagnostic devices now. What that means is the diagnostic device comes to the patient instead of the patient going to the traditional setting like in the hospital or the clinic. So what I can do is go to something like Now Diagnostics, which I can do a blood draw in my own home to test for certain diseases. Or take, say, the AliveCore EKG monitor. What that is an iPhone case, or it fits on your iWatch, retails for less than $100, and it's FDA approved, right? So what I can do is take my clinical grade EKG data, send the data up to the cloud, where it's going to be analyzed by artificial intelligence. And with the widespread adoption of telepresent medicine, I can now, of course, see my physician via FaceTime, Skype, or even telepresent robot. What about potentially getting my medication delivered by drone? Well, we are starting to see this being utilized more and more. In fact, a company called Zipline, with $19 million of funding, plus a grant from UPS, has gone into Rwanda, and they'll be launching, pun intended, next July, just about a month from now. And they are trying to do an entirely national system of drone delivery for healthcare and medicine. Now, people think that Africa is a hotbed of drones because there's no rules and regulations. Fact, what it is because they have an opportunity to be able to create these rules and regulations and systems without having to go into the stuff that we have here in Europe and the United States because it's such a complex system. They have the opportunity to do it from scratch and very quickly. So that's why there's a lot going on in Africa. And Rwanda is going to be the first country in the world with an entirely national system of drone delivery. We're starting to see drones being utilized in other areas of medicine. This is a company out of the EU. They are doing essentially flying defibrillators. They are hoping to be able to get to a heart attack victim in under 60 seconds. Now, if they are able to achieve this, they can increase survival rates from 8% to 80%, right? And flying cars, we now have them, right? This is a one-person ambulance drone, carries 260 pounds and can fly for about 23 minutes. They unrevealed themselves at CES this year, and they're already in conversations with a company called Lung Biotechnology out of the United States. What that is a company that's working on tissue engineering for organ transplants. And they're already talking to this company about getting 1,000 of these ambulance drones, right? So we are entering a perfect storm right now of technological advancements really enabling what I like to call the era of the patient. So I'll go quickly through these 4 categories, talking about the medical science. And of course, we all know genetic sequencing is not only on the exponential trend, but it is dramatically outperforming Moore's Law. 2001, it cost $2.7 billion to get to that first genome, and $100 million to actually sequence it. Today, this year, we have passed the $995 mark. That is the inflection point that experts the world over agreed in genetic testing would make the difference, right? That means over the next decade, we are going to see the dollar, if not the penny genome, and we are going to be able to afford to sequence the world, right? Talk about a massive amount of resulting big data. We'll be doing predictive analytics, early onset diagnostics, and hopefully even a leap towards stage 0 medicine. And this, of course, is enabling precision or personalized medicine, meaning a treatment plan based on the individual, including their genetic makeup, versus that one-size-fits-all model that we've been experiencing up till now. And the microbiome. Raise a hand, how many people were here yesterday and got the foundation for the microbiome? Okay, another raise of hands, how many people have heard of the microbiome? Okay, that's pretty good. So what that is the colonies of bacteria that live in and on our bodies, right? It's different on your arms than it is inside of your GI tract, which is different, again, from your head, right? Now, symbiotic relationship. We need them, they need us, right? And in fact, we are less than 50% human cells. 50% of the cells in our body are actually bacteria and viruses and fungi. But we have not been taking this into account in medicine up till now. But genetic sequencing technology is catalyzing breakthroughs in this. The US government about 2 or 3 weeks ago actually launched a $500 million initiative, over $500 million going to being able to understand the microbiome, not just the human body, but the microbiome and the environment, right? About $100 million coming out of the government, $400 million coming out of the private sector, including the Gates Foundation. So let me give you a couple of scenarios, right? Imagine I have Crohn's disease. I bank my microbiome, just like you bank umbilical cord blood, right? And when I'm feeling really well, and then if I'm not feeling well, maybe I get a transplant back of my own microbiome, right? Or this one blows my mind every time I say it. What about some of these diseases that we thought were infectious? Were genetic, right, passed down? In fact, turn out to be infectious through the microbiome. All right, so let's talk a little bit about the software. And hang on, I'm going to get some water. So of course, artificial intelligence is a huge buzzword this year. And in fact, we have probably hit the inflection point in this technology as well. Now, it's been quoted by experts the world over. Once AI works, no one actually calls it artificial intelligence anymore. We have been using AI in our daily lives, all of us in this room, for years, right? Gets especially exciting, of course, in healthcare. Now, IBM Watson is one of the companies really leading the way in AI applied to medicine. Now, look at those stats. As a human being, that's just what Watson digested like the first time it went to medical school, right? As a human being, how in the world can you remember all of that and be able to recall it in a millisecond? You can't, right? When you combine that with the fact that there are over 10,000 known human diseases, right? How is a physician supposed to keep up with the sheer amount of information coming at them, right? They can't. And yet all of this time, we've been going in as patients and saying in these 10-minute or 15-minute doctor visits, I'm sick, cure me. How are they supposed to do that in that sheer amount of time, right? But artificial intelligence is fantastic as decision support software and really enabling the physician to help with the patient, right? And the reason physicians like AI is not because it only gives you the top 3 probabilities of a diagnosis, but it also gives you the evidence trail behind it, which is so very important. And IBM Watson has opened up their API for anyone to use. Whether you're an entrepreneur or a Fortune 500 company, you have access to using Watson in whatever you're doing. Now, why would they do that, right? One of the world's most powerful computers? Well, besides the obvious revenue stream, is because AI actually improves more quickly the more it's used. And when you're talking about deep learning, you literally need trillions of data points, right? And AI in the mental health care space has already outperforming therapists, right? This is fantastic and so cool. Give you a few examples. Talkspace plugged into IBM Watson's open API for personality, and they match you to a therapist based on your personality. This is a big deal because if you do need therapy or you want it, and you go into a therapist and you don't mesh well with their personality the first time out, you may never go back, which means you may never receive the help that you need. Right? And Ellie is really cool. So outperforming therapists already in PTSD and depression. Now, not only does Ellie analyze responses to queries that she asks, just like a normal therapy session, analyzes tone of voice, right? Facial expression, and even the subtle way you string words together over a period of time, whether that's hours, weeks, or months. Again, how can human beings do that? We can't, right? And psychosis, wow, this one blows my mind as well. So it turns out about 1% of everyone between the ages of 14 and 27 are at risk for developing a psychosis later on in life. Well, IBM Watson did a study, was able to predict with 100% accuracy. 100% accuracy? Those people that did go on to develop a psychosis. I don't know about you, but that's the program I want running in the back of my phone. And we're starting to see a wide array of emotional robots hit the market. The cute little cat, well, I bought that for myself for Christmas. It's adorable. It's a $99 Hasbro cat, specifically for elder care. And it's actually quite comforting. If you're very isolated, this is a fantastic solution. But the one right here, that's Pepper. Developed in Asia last year. Launched they made 1,000 units, sold for $1,600. And they sold out in under 60 seconds, right? So far, Pepper has now have about 10,000 units distributed throughout Europe and Asia, and hopefully will be hitting North America this year. It's an emotional robot, so basically all it does is it just talks to you and provides company and companionship. It doesn't actually do anything besides just be a partner for you, right? So we talked about medical science, talked about software. Let's delve in a little bit to hardware. And you guys have heard of the phrase, the Internet of Things, right? Well, I'm thinking about an Internet of You. We are experiencing a paradigm shift right now. Everything is going digital. In fact, and sensor technology, of course, is catalyzing this. By 2019, it is expected that the sensor and healthcare market is going to be a $50 billion a year industry. Massive opportunity, right? That is 3 times the size of the global music industry. And we're starting to see a wide array of biometric smartware hit the market. So it's gone completely mainstream. Companies like Polo Ralph Lauren and Intel, of course, has its own version of a smart shirt. That is not something I ever thought I would say. Polo Ralph Lauren and Intel going head-to-head in the clothing market, right? But we're seeing a lot of companies also get into the clinical space. Companies like Sensoria, they are developing socks that measure gait for neurodegenerative diseases. And HealthWatch is a company out of Israel doing a 15-lead EKG monitor compression shirt just for clinical use. But the cool thing about technology is it makes things seamless. In fact, I'm not wearing a quantified self device today. Why? Well, my battery died, of course, again, and I lost it, put it down somewhere again. And frankly, it's not going to go with this outfit, which is a huge consideration when you are talking about patient engagement and compliance. Because if a patient doesn't like the way something looks, they're not going to use it. But technology makes things seamless. The way I see this going is things like epidermal electronics. What those are temporary tattoos, stay on your skin for about 2 weeks at a time, and do continuous biometric activity monitoring. Companies like MC10 have partnered with L'Oreal Cosmetics, of all companies, and they are doing an epidermal electronic that measures UV radiation. MC10 is also trying to develop one that measures glucose in sweat, right? And the one in the upper corner, that is Abbott's diabetes monitor, launched here in Europe in October. Of course, a major game changer, because what it is you put it on, has a little filament that goes right under the skin, and it measures your glucose every 1 minute. Right? What a game changer for diabetes, let alone people who just want to monitor their blood sugar, right? Athletes or just normal people. And these companies are working on contact lenses with sensors. Verily is the life sciences department at Google, and they are doing contact lenses that measure glucose. Sensimed already has FDA approval, contact lenses that measure glaucoma progression. And we're seeing an entirely new category called ingestibles, both things like sensors on pills, but also companies like, universities like MIT. They are doing a vital sign pill. So imagine on a daily basis, you pop your vitamin pill and you pop your vital sign pill. And 3D printing. So we saw some really cool things in 3D printing yesterday, so I'll give you just a few examples of it applied to the medical space. Now, the biggest concept, of course, when walking away from here in 3D printing is that complexity is free. Meaning, costs the exact same amount of money to 3D print something perfectly fitted for my body, personalized completely around, if I want designs on it, maybe I want, a cast with my favorite rock star on it, right? It costs the same amount of money as to do one that's completely plain. And Stratasys just came out with a 3D printer that does 360,000 different color variations in one print job, right? And we are now able to 3D print in over 300 different materials, including asteroids. Give you a couple of examples. The ones in the top, those are 3D printed titanium body parts, right? How cool is that? And how many people in the room have had a broken bone in their lives, had a cast? Raise your hands. All right, quite a few of us. I've had 2. Do you remember how uncomfortable they were, right? You couldn't get them wet, they smelled, they were heavy. The treatment plan for a broken bone was torture, right? Well, we can now do 3D printed casts with holes in them for scratching that are completely waterproof, right? And that one in the corner, that is really cool. It's a 3D printed hand made by a company called Enable. Enable is a nonprofit with 8,000 volunteers worldwide, and if you are especially in the developing world, you can't afford a prosthetics. They cost thousands of dollars, right? But Enable will 3D print one for you for free, right, and send it to you. So all of a sudden, you now have access to free prosthetics. And this is Aimee Mullins. She is a double leg amputee. She lost both of her legs at a very early age. She doesn't think of herself as disabled. She has 12 sets of legs. She wants to be 6 feet tall? She is. She wants to be 5'6" the next day? She is, right? She has a set of legs that allow her to outrun every single person in this audience. Do you call that disabled? Right? And this is a physician out of Gaza. Of course, he couldn't get his hands on a stethoscope, right? It's very difficult to get supplies there. So he created one with a 3D printer himself that cost under $5, right? Now, as he says, the data behind it is as accurate as the $200 models that you find in Europe and Asia, right? But that means the most ubiquitous object in medicine just got disrupted. All right, so talk a little bit about infrastructure. So just like with banking and education, infrastructure and content are separating. You are no longer constrained to a physical venue just to receive healthcare. In fact, you aren't constrained to a physical venue to do just about anything right now. Jobs, education, social lives, even our relationships are going digital. It's expected over the next few years, an additional 3 billion people will be coming online, right? And there are a lot of companies who are helping catalyze and make this happen. Companies like OneWeb, they've partnered with Virgin Galactic with $500 million of funding. They want to put 600 satellites up in orbit to provide the world with wireless, right? Elon Musk is a direct competitor with 400 satellites and $1 billion of funding. X is out of Google. They're the moonshot division. They are doing something called Project Loon, big, huge hot air balloons that circumnavigate the globe, right? Provide internet access. And internet.org is Mark Zuckerberg's brainchild. He has been quoted as saying that connectivity is a human right. Right? He has partnered with big companies like Samsung, Qualcomm, and Nokia, and they are trying to not only make it 100 times faster, but they will be able to provide access with drones. Yep, and I'm done. And all of this technology is really raising the bar on the interaction between the patient and the physician. So if you think back to the title of my talk, The Patient as the CEO. And just like the CEO of a corporation, where you surround yourself with a fantastic array of vice presidents, support staff, advisors, right? They do their job, report back to you, and together, as a team, you decide on a direction for the company to go into. But as CEO of a corporation, you are the one who is ultimately responsible that that vision is carried out, and then the company overall is successful. Why should being a patient be any different, right? Thank you.